charge there is 0. You have plus 1 times 12 plus 12 charge. I have to make it 0 because this is 0. How I'm going to make it 0? Put 12 what? 12 electrons, because 12 times minus 1 minus 12 plus 12, 0. Right? Okay. Let's go to the second one. Non-hydrogen and oxygen elements, we don't have. Then we do what first? Oxygen. So we have 2 oxygens, I have 1, so I put 2 there, that's it. Now we do hydrogens. I have 0 hydrogens, I have 4 hydrogens there, so I need 4 hydrogens here. In what form? In this form, as protons. But balanced by mass, already, by charge now. This is 0, this has to be 0, so I put 4 electrons. Cool? This should be fun, really. This is not chemistry, this is just playing games in the sandbox. When you were a little boy and a little girl. What? Well, you're following the process. That comes out by following the process we do it. Follow how we do it here. That's the answer, really. Now, the next step is going to have the same number of electrons, right? Same number of electrons. You have 12 here, you have 4 there. So we'll multiply with a number to make them equal, right? So you will have to multiply this one by 1. By 3. 3 times this. If I take 3 oxygens, then I'm going to have, I will need 12 electrons, which I have from there. So 12 in, 12 out, they cancel, right? So now I'm going to have to write this again. You see, I have to write this again. But very careful. You say 3 oxygens plus 3 times 4, 12. 8 plus 3 times 12, 4, 12. 3 times 2, 6 waters. Okay, so now we have these, let's call it A, and these, let's call it B. Alright, so A plus B, it will give me what? You add this and that. That means I add this together with this, and this together with that. So it will be here and there. Imagine it, right? Imagination. So this will go away with this. This is going to go away with this. Then we have, but now remember, don't try to work this and sometimes with this and sometimes that. that's a trap, right? You are concentrating here and there. You might do like this, so that way you will not make a mistake. This one and that one. Because if you start doing some here and some there, you're in trouble. All right? So now we have the waters, right? I'm working here and there. I have the waters, 3 here and 6 there, so 3 are gone, and the 6 becomes 3. That's it. So you write now, very carefully. You start from the left, on the top, we have C2, H6O, plus nothing, plus 3 oxygens, plus nothing, goes to CO2, plus nothing, plus 3 waters. That's it. Right? Any problem is done this way by the half reaction method. No physical states, no mention about at all oxidation reduction. Somebody can do it without knowing anything about reduction oxidation. Teacher is very excited about it because you know there's not in any chemistry book like this. Very cool. Because when a problem is telling you just to balance the chemical equation and it doesn't ask any questions about which is reduced, which is oxidized, this is the best way to do it fast. You don't have to deal with anything else. Now, it's a problem asking you questions that relate to what is the oxygen does, you know, what the reductant does. It's a very good set of questions that the teacher puts every time, because when you take biology or other classes in chemistry, you will need to know the terminology of this stuff. There's terminology, right? Oxidant, reductant, reducing agent, what it does each, when, right? So in order to answer these questions, all these questions that you see here, right? In order to answer all these questions, there's no way to avoid now doing what? Find the oxidation numbers. To find the oxidation numbers to be able to answer these questions. Okay, so let's write down the oxidation numbers so that way you can do it. Perhaps we can use red. Where's my red? Here. Okay, so let's see. First of all, notice, if you do things correct, one of the equations will have the electrons on the right and the other will have on the left. They cannot be both on the same side. One has to be oxidation, otherwise it will be reduction. So electrons one time here and one time there. It cannot be on both sides, right? Another thing that you can notice, and you already know, is if electrons are produced, right, that means something lost electrons, all right? If electrons are in the project, some lost electrons, right? Well, that's something. If you lose electrons, the oxidation number of one of its elements, the oxidation number is going to go algebraically up or down. Minus goes away, what will happen to the oxidation number of some of its elements? Go up, algebraically go down.
Up.
Up, right? The opposite is going to be for the other reaction, this one. So what's the oxidation number of carbon here? Because you see, hydrogen is always +1 when it's with a non-metal. Hydrogen is non-metal. Carbon, oxygen, they're all non-metals. So hydrogen, when it's connected with something which is non-metal, is always what? +1. So no change. Oxygen is always -2 when it's with non-metals. So it's carbon, hydrogen. Whenever you see an organic compound, that's an organic compound, carbon, right? Hydrogen, oxygen, it's going to be always -2, unless it's a peroxide. That's very rare, okay? So it's not going to be the problem, unless the problem is telling you it's a peroxide, okay? So it's always going to be, practically speaking, -2, oxygen -2, for organic compounds, carbon, hydrogen, oxygen compound. So if that's the case, then yes, oxygen is going to be -2 here, -2 there, -2 there, yes, but this is element. So element has how much? 0. 0. Let's put the oxidation numbers below the formulas and the charges on the top as a converter so we don't get mixed up, right? It's good to practice that. So oxygen goes from 0 to what? It goes to -2. You can put -2 here if you want, that doesn't matter. So it goes from 0 to -2. You can put -2 there if you want, that's fine, doesn't matter. And the carbon, right? Carbon goes from -2 plus times 1 -2. +1 times 6 plus 6, so +6 -2 makes?
+4.
+4. This is +4. I want this to be -4 because it has to be 0. If this has to be +4, 2 times, what will give you +4?
+2.
Actually -2. -2 plus 6 makes what? +4, I mean -4. 2 times -2 will give you -4, right? So it's -2 here. And carbon here is, oxygen is -2 times 2 -4. This is 0. -4 from oxygen. The carbon has to be +4. So carbon goes from -2 to +4. And oxygen goes from 0 to -2. Okay? If you do that, then all the questions are really easy to answer now. It says, the oxidizing chemical species is, so you're thinking, the oxidizing, okay, if it's izing, I-A-G, izing, right? It does something. Oxidizing does something to somebody else. It's oxidizing and it itself is reduced, right? So if it's reduced, the oxidation number will have to be reduced algebraically, yes? So reduced algebraically, which one is it? 0 to -2, right? That's, so the oxidizing chemical species then is oxygen, right? Can you see that? The reducing chemical species then is going to be the organic compound, right? because the reducing will be reducing something, will be oxidized, so the oxidation number should be algebraically be increased. And from -2 to +4 is an algebraic increase, right? All right. The name of the oxidized element, which is the oxidized element? From -2 to +4, that is oxidized. So the element which is oxidized is carbon, right? It specifically tells you the element. It doesn't tell you which compound. You have to be very careful with the terminology, right? It does not ask you which compound is oxidized. It says which element is oxidized, carbon. And then it tells you the name of the reduced element, from 0 to -2, reduction of algebraic number, algebraically. So the name of the reduced element is going to be oxygen. Now, there is another terminology equivalent to what we saw before. Oxidizing and reducing agent, right, is also equivalent to say, instead of oxidizing, you can say oxidant, right? So if the oxidizing is oxygen, the oxidant is same, oxygen, because oxidizing and oxidant is the same thing, just different words, right? The same thing with the reducing agent. The reducing agent is also called reductant. Okay? You have to be familiar with this term because it will be always used in organic chemistry if you take organic chemistry. Now it says the element G. The name of the element that gains electron is, well, it will gain electrons, that will be, the oxidation number is going to go algebraically down, right? So that's going to be what? Oxygen. The element that loses electrons will be then carbon. The chemical species that causes oxidation. It will be the oxygen, right? Oxidizing agent, right? It's just the same thing but different terminology. And then the oxidation number changes. We already did it. So here's the answer, right? This problem, really you should do it, okay? 16 points from 100 points. You should not miss it. Not because it's the same. The only difference will be the equation. You should not miss this problem at all. If I was you, I would just do the first thing I would do, I would be that problem. Right? You should not miss it. Okay, now, we still have 10 minutes. We can do, let's see which one we can do.